This is Nanoscape. I'm Seth Zimmerman.
And I'm Erin Spain.
On this show, we venture into the frontier of nanotechnology
with experts in the field who are turning the science of small into the next industrial revolution.
This podcast is brought to you by the International Institute for Nanotechnology at Northwestern University.
Last year, we welcomed Dr. Omar Farha to this podcast just as he was appointed the new chair of the Department of Chemistry at Northwestern University. This is a 3-year term at one of the largest departments of its kind in the country.
Omar is not only a leader here at Northwestern, but in the field of nanotechnology. His seminal contributions to the field of metal organic frameworks, or MOFs, are accelerating their potential for applications that could help reduce energy consumption, protect human health, counter climate change.
We are thrilled to have him back on the show to talk about his first year as chair of the department, his latest MOF research that involves atmospheric water harvesting, collecting water directly from the air, even in places where rainfall is rare or groundwater is limited.
Welcome back to Nanoscape, Omar.
Yeah, thank you both for having me again. It's always a pleasure to talk to you, Erin and Seth.
Fantastic to have you back.
We'll dive right in. Describe the Department of Chemistry here at Northwestern, and why did you say yes?
No one, or at least most people, they don't want to do this job, being the chair of a department, because it comes with its own challenges and responsibilities that take you away from what you do best, being a professor and mentoring students and postdocs. However, once you accept the job, you have to give it your 100%. And I am actually honored and lucky to be the chairman of a department like Northwestern Chemistry Department, one of the top chemistry departments in the country and the world. It's a giant, visible department, and my colleagues are at the forefront of science.
This department has served as home base to some incredible giants in the world of chemistry and nanoscience, including Sir Fraser Stoddard, a cherished member of the Northwestern community who passed away this year. Can we reflect on that news and the impact that he had on the Department of Chemistry and the world of nanoscience?
Oh, absolutely. I mean, first of all, Northwestern has 3 Nobel laureates, 2 of them from the chemistry department and 1 from economics. So they all reside under the umbrella of Weinberg. That's the college we are in. And that's something we're always proud of. When Sir Fraser was recruited here, that was done by the IIN director, Chad Merkin, and the former president of Northwestern University, Henry Beenan. What an amazing 2 people to think about how can we bring Fraser to Northwestern. And they succeeded to bring him here. And he took the caliber of Northwestern from being a great school to a spectacular school. He helped us recruit a top faculty to our department, better postdocs, better graduate students. So Sir Fraser really single-handedly made Northwestern chemistry better.
Yeah, what a loss to the community. I know a lot of folks have been mourning this loss.
I was one of the lucky ones to have my lab on the same floor as his lab. When we both in town and he's eating his cheese and fruit in his office and his door was always open, never closed. And I will always try to steal some of his time and wisdom.
You're leading a department, you're working in the lab, and your startup companies are continuing full speed ahead. So let's refresh our listeners' memories about your group and your role as co-founder and president of NewMat Technologies.
Let me add to that I'm also an executive editor for one of the largest journal at the ACS. I am a believer, if you want to run multiple things and you want to run things at a scale, you cannot be a micromanager. You have to be a delegator. You have to hire people smarter than you. You have to surround yourself with awesome staff. And I am lucky to have the best staff in the world in all 3 areas. It takes more than faculty members to make a department awesome. The first thing is our students, postdocs, and our visiting scholars. Because we could have all the ideas in the world if we don't have the people to go to the lab and implement and make these ideas reality. There will always be ideas sitting either in our head or on our desktops. That's it. We have the best students in the world. We have the best postdocs in the world. Visitors from all over the world come to our department to learn how we do things and take it back to their institutions. The second thing what makes a department great is the staff. Because without the foundation, nothing really survives. And our staff is really the foundation that makes us who we are. Third, you need shared facilities without the instrumentations. And Northwestern is really awesome at having the best instrumentations beside national labs. We have our facility IMCIRC, we have Nuance, you name it, anything you want, you could do. And lastly, faculty. You put all these pieces together, and that's the recipe for an awesome department. Other places have great departments too. You look why they are not Northwestern, you will find out those four things didn't come together. They might have two of the four, or they might have three of the four. But in reality, if you don't have all the four, and they need to be working in concert, all four things. And somehow Northwestern did it right.
And you're carrying on that legacy. This has been set by the folks that came before you, as you mentioned, but keeping that culture and keeping morale high, especially during what is really unprecedented times. Talk about that. How are you able to really keep people focused on the work?
One of the things I did in my first year that we all proud of, especially me, is concentrating on the culture. People like to get together around food and drinks. If there is food and drinks, people love that. And we try to do as many events as possible. We try to keep people engaged. But I always believe resilient departments, they show up during hard times. If you look at things from a different lens, not just from the difficulty lens, we are in the United States, best country on earth. And we are on Northwestern University, one of the best departments in chemistry. As hard as it can be, it could get worse. The question is, how can we get together and say, we want to go through these hard times? We've been through it before. We called it COVID. But the main thing is unity. And when you think you are alone, I guarantee you, if you are at Northwestern Chemistry, you're not alone. We're in it together. A place like Northwestern, we have an institute that is the best nanotechnology institute, not nationally, but internationally in the world. I don't think this year or next year or 10 years from now, we got to slow down. I think the only thing you got to see from nanoscientists and material scientists at Northwestern, that every year it's going to get better.
As you've been doing all this work, you're leading the department, you're still working on your startup companies, you're recruiting faculty and students, all of this work. You've been able to publish more research. So let's talk about one of your recent publications in ACS Materials Letters. This has to do with, of course, your MOFs. Tell me about this latest paper and this idea of harvesting atmospheric water.
We are not the first ones to tackle this problem. How can you use metal organic frameworks for water harvesting? There is few groups around the world, and our contribution here is how can you make materials to withstand the cycling of on and off, to get hundreds and thousands of cycles, be able to capture water in environments when people think there is no water to be had or be captured, and convert that into drinking water. All that started under a program called Victor, and it was for DARPA. How can you make a small device that has the ability to capture and release water for drinking for the soldiers? With the idea, once you know how to do that, then you could scale it up to larger devices and be able to use it for our houses. And there is few startup companies are in the world right now that are tackling water harvesting using MOFs. And somebody might ask, why MOFs? Why not other materials? Right now, water harvesting devices do exist. You could go buy one from Home Depot. It's called a dehumidifier. The only problem with the dehumidifiers, they don't work under conditions that you have to have 50% relative humidity or higher. Very wet. Relative humidity less than 50%. We do not have the materials that can do that with the right energy perspective. That means capture the water and release it easily without having to cost you a lot of energy. Because we could, let's take zeolite. Zeolites is it's the cousins of MOF and other porous materials. They are awesome. They will capture water greatly, but they capture it and they keep it that is hard to release. The water sticks to it very strongly. And you have other materials such as activated carbon. which doesn't like to capture water at all. MOFs is metal organic. You have the carbon, you have the organic, you have the metal. We have thousands of these materials to choose from that we could really tailor it in a way that we make that sponge sticky enough to water, but not too sticky that we cannot release the water. And that's why when I always talk about MOFs, I hardly call them metal organic frameworks. I call them smart programmable sponges, because in reality, that's what they are. They are sponges and they are smart, and we could program them to capture water, but not other things, to capture CO2, but not the water, and vice versa.
How do you see these findings that you just published in ACS Materials Letters forming future directions in water harvesting and other MOF-based applications?
My student, Owen, who's the first author on this paper, what he did here and his contribution to this area is how can you make sure the cycle time is very short. That means you want to capture and release water as many cycles as possible in a 24-hour, which gives you higher capacity and higher amounts of water per day. And he went about it by engineering certain defects and removing certain blocks from the material, making it more into kind of Swiss cheese type of material that allows the water to go in faster and come out faster. So he made highways that takes you to the side streets instead of side streets all the way.
I mean, we usually don't think about defects as being something that could help improve a product.
You're absolutely right. And that's why a lot of times we go to MOFs, because they are pristine, they have less defects, we know. But in this case, he took something that it's great at capturing water into something fantastic at capturing water. So he built on a previous paper that we also published in the group.
This really does showcase these brilliant students that you were talking about and this thinking outside of the box, really.
Absolutely. We are proud at Northwestern to recruit the top students in the world, not just in the country. This is an international department, and we recruit from all over the world. We recruit the best of the best. We get more than 650 applications per year. Our cohorts typically ranges between 45 and 55 students. All the applications we get are spectacular. Now try to bring a 650, 700 applications to the 45 and 50, even though I would say the majority of them are incredible applications.
Yes, I don't envy that job.
I've done that job for 3 years as the admission chair. And right now it's my colleague, Julia Kalo, and she has been doing a phenomenal job.
In 20 years, we're going to have you fill in the blank here. In 20 years, people will be shocked that we didn't use MOFs for...
Honestly, I have no idea, because every year I read beautiful papers from the globe that are putting MOFs in different applications. And right now, you want to think of medicine? People already starting to do that. You want to think of energy and batteries? People starting to do that. You want to think about catalysis? People are already starting to think that. Every time I think there is no more application to put MOFs in, I get surprised. And right now, the answer, I really don't know. But I always look forward to the young people, the new generation coming with these great ideas that mid-careers like me and our senior colleagues have not thought about. And that's the beauty of science.
What are some of the most ambitious, or scratch your head, I would have never thought of that, applications that are being used right now or being tested right now?
Think about being able to capture and detoxify nerve agent on demand instantaneously. If we thought about these applications 20 years ago, we would have thought this is craziness. Be able to store some of the toxic chemicals that the semiconductor industry use it and release it on demand in a safe manner. Again, these are applications 3-4 years ago. I didn't think we could make materials that are stable up to 300-400 degrees Celsius. I thought the organic is going to burn off to CO2. And I thought we stuck with things around 150-200. Now we are making materials that they could reach that part of the heating 300, 350, 400. Now that's going to start opening up areas in catalysis that just 3-4 years ago, we didn't think we could even go there. So I cannot imagine what the new generation will do 5 years from now, and how they could open up areas that right now I would say I don't think MOFs can play a role there, but they will prove me wrong. And I always like to be proving wrong when we talk about science.
As we wrap up, what message would you like to give to your fellow colleagues who are working in nanoscience as a leader in this field, not only at Northwestern, but internationally?
We have an institute that is the best nanotechnology institute, not nationally, but internationally in the world. I don't think this year or next year or 10 years from now, we got to slow down. I think the only thing you got to see from nanoscientists and material scientists at Northwestern that every year it's going to get better.
Omar, thank you so much for coming on the show again. It's fun to hear all that you have in store for the department and also the work that you continue doing for nanoscience.
You know, it makes my job easy when you lead a place like Northwestern Chemistry.
Thanks so much for listening. This podcast is brought to you by the International Institute for Nanotechnology at Northwestern University. Be sure to follow this show on Apple Podcasts or wherever you listen to podcasts, and be sure to give us a 5-star review.
For more information about IIN, go to our website, iinano.org/podcast.